Hello, this is Junichiro Horikawa, and this is the tutorial for geometry nodes for Blender 3.1. And what I'm gonna show you today is to create this procedural raining garden inside a box. In terms of the proceduralisms, there are several parameters that I have set in order to change the action of this setup. For example, the size of the whole box, the density of the rain. You can also change the direction of this raining by changing this arrow direction, like that, like that. For the other parameters, you also have like the maximum speed, minimum speed. You can change the speed, how fast it rains, or you can also change the maximum length and the minimum length of this rain. Which also changes the thickness of the rain. First, let me explain how this works. First, you create a boundary. Then next, you create a bunch of points surrounding the boundary box. And you define in which direction the point will run to create a raining. It's the initial setup, and once you define the velocity for to move the points, you just need to move these points to this direction to create a line and the animation. Now once the point goes outside the boundary, like here, you want to respawn these lines which went outside from the other side of the box, in this case somewhere around here. And you want to do this for every point that goes outside the box and respawn to a corresponding other side of the box, and so on. That is to keep the density of the raining the same. Now that's the whole setup for this raining garden. Though one things you want to do in the final setup is to trim out those lines which is outside the boundary box in order to clip to see that it's inside. It looks like it's inside a specific box. So in order to do that, I'm gonna use the shader programming or shader visual node to clip the raining outside the box. Okay, so let's start doing this. Let's start creating this. First thing I would like to do is to create a basic element for the raining, which is just a line. So in order to do that, I'm first going to decide which of the geometry to use the geometry nodes on. So I have just renamed the cube to raining garden. So this is what I'm going to use to attach the geometry nodes. I'm also going to create an empty geometry which is going to be used to define the direction of the rain. So I'm going to choose the single arrow to do this. So I'm going to move this a little bit to the off. Now currently it's facing upward, but I'm going to make this face downward with some angle, which I'm going to use this to define where the rain goes to animate and to create the line shape. Okay, so let's go to the geometry nodes layouts by clicking this tab and select the raining garden, which is a cube, and create new. Okay, I'm gonna name this to raining garden. Alright, so first thing to do is to just disconnect the wire, and what I'm going to do first is to create the single line elements which I'm going to animate on top of the inside the box boundary. Okay, so let's create a line geometry first, and to do this I am going to create a node called curve line. Okay, and what I'm going to do is to define the direction of the line first with the length of 1. I'm going to change the length later with the instance scaling. So in order to do this, and I already have the information in which direction I want to create the line, which is defined by this empty node. Let's also rename this to direction. Okay, and what I'm going to do is to drag and drop this directional geometry inside the geometry nodes that I can refer to this geometry. And now that I have this geometry node, what I'm going to do is to get the rotational information from this object and use it to define the direction of this actual curve. So I'm going to connect this line to this geometry output or group output so that I can see it, how it looks like. Right now it's facing upward. Okay, so from the object that I have just imported from the directional empty node, I have this rotation output, so I can use this to define the actual direction. Now this rotation is not a vector value itself, I mean the directional vector value itself, so I need to use this to rotate the actual vector to define the actual direction, which I am going to apply it on the end of this curve. Okay, so in order to do this, what I'm going to do is to currently, you can see that the direction is going upward as a default value. So I'm going to create a dissimilar directional value, which is 001. And what I'm going to do is to rotate this vector value with this rotational value, which is the Euler angle value, using a vector rotate function. Okay, and in order to do that, I'm first going to connect this one, which I want to rotate, and then connect this rotation to rotational input, which I don't have it right now, so let's change the type to an Euler. Okay, now there's an input called rotation, so I'm gonna just directly connect this right here. And now I'm going to connect this result to the end of the curve line. Now I can see that the line is aligning to the direction that I have inputted. So now that I have this being set up, if I rotate this direction, you can see that the line is also rotating along with this empty node or empty geometry, a arrow geometry. Okay. Now in order to render this raining, you need to have a mesh instead of the curve. So let's also create a mesh out of this curve. In order to do that, I'm going to use a curve to mesh. And I'm going to create a pipe shape using a circle as a cross section. So I'm going to create a curved circle as well. Now, to make it faster in order to calculate the animation, I'm going to make the resolutions pretty low, like 6. And if I connect this to the profile curve, maybe the radius is a bit too much. So let's make the radius pretty small, like 0.015 or so, which should be enough. Okay, so this is going to be the base for the raining, and later on I'm gonna scale this shape up and down to make some randomness and so on. Okay, so this is one set, so I'm gonna make a frame to group this together, and let's name this line or a base line. Now, next thing I would like to do is to scatter or distribute these rain geometry inside specific box shape. So to do this, I'm going to make this single line elements as an instance and create a bunch of instances inside the box. So to do that, I am going to use a instance on points. And in order to use this, you do need a bunch of points to distribute. So let's also create a node called a distribute points on faces. In order to use this, I'm gonna connect this points to this instance on points. And in order to use this, you do need to have a mesh to have a bunch of points on top of those mesh. So it can be any mesh because what I'm just going to change the point position of those points created on this mesh later on with some random values. So I'm just gonna create some any kind of mesh, which could be like a grid, like this one. So it could be just a simple geometry. And I'm going to change the size. I'm not going to really change the size. Maybe the vertex to 2 by 2, and connect this mesh right here, right? Like that. And anything else? I could also change the density here to define how many points I want on top of this grid. So by changing the density, you could change like how many points you want to create. Let's test this out by connecting this line to this instance and see how it looks like. So if the density is equal to 10, you have somewhere around this amount of points, and if you increase the density, you see that you start to have more points or more instances like this. Right, so you can see that by changing this density to 1, you actually have 1 point. If you're 2, it's 2 points. So this is equivalent to the number of points you have on a grid. So let's create a parameter so that you can control right here to control the number of points. So in order to do that, I can open up the tab by typing n, and there if you go to the group, you can define the input. So let's create 1, and let's create the number of points by saying like point number, something like that. And then let's also change this to an integer, and minimum is probably 1, and maximum, I don't know, could be any number, so let's just leave it as it is. And I am going to create a group input which will have this point number as an input. So let's connect this to a density, and let's change the point number input or parameter that has been created to this geometry node modifier, and you can see that you are now controlling the number of points to be generated or distributed. Now that I defined the number of points, the next thing I will do is to define the position of each point. Now, without thinking about the animation first, let's try to distribute these points inside specific size of box. So, in order to do that, let's define the size of the box first by creating another parameter. So let's create another input, and let's name this to a box size. Okay, and it should be positive, so from 0 to something. Minimum is 0, maximum something. And let's set this to something like 6 for now. Now what I have just defined is the size of the box, which can be used for the height, the width, and the depth of the box. Okay, so I'm gonna set every width, height or depths to be the same for now. Now let me just show you in 2D how I'm going to distribute the points. Now let's say this is the actual box that I'm going to use to trim the rain. Now in order to create the laning, what I'm going to do is to create a virtual box which is larger than this original box in order to trim the rain. And I'm going to use this virtual box to actually create the bunch of lines. And I'm going to move these rain to this direction. The reason is because what I want to do is to respawn the line which goes outside the box, the box on the center, and respawn this line that goes outside this original box from the other side of the box. Okay, so that it looks like within this box the line seems like goes from the line like this and slowly disappear to a length of 0 and shows up from the other side, starting from the size of 0 and gradually shows up like this. And in order to achieve this, you should have a bigger area or a bigger box area to spawn these lines so that we can have this gradual line changes with the shader later on to trim with this inner box. Okay, so I already have the parameter for the box size, so let's create a random vector value which is going to be used as the initial point position of the raining lines by creating a random vector values first of all, using this box size as a domain. So let's first create the random value. Oops. By using the random value node, change this to a vector, and you need to specify the minimum value for the vectors and maximum value for the vectors. For the maximum, I'm just gonna connect this box size to this max. And let me also change the box size value to a float. Okay, and change this to 6. Also, for the minimum, I'm going to set the negative value of this box size so that it will be. So if this is box size, but the one that I'm going to create is the random points, which is the 2 times larger box than the inner box. So in this case, if this is the x axis and this is the y axis, and if the box size, inner box size is w, then in order to create the random points on the double size box, you just need to set the maximum is positive x and negative is negative w, a positive w and negative w. So, and then this is the box size. And same for the y direction and z direction as well. So let's do this by just multiplying this box size by -1 and placed it in minimum. And by doing that, you'll be able to get a double size box with a negative value, a bunch of negative value inside those box. So let's create a math node, multiply the box size by -1 and connect this to minimum. And since if you connect the float value to a vector input, then all x, y, z coordinate will be used with the same input float value. Okay, now that I have this random vector values, I can Then connect this to use this to set the position for this instances. So let's do this. So what you can do to change the position of instances, first of all, what I could think of is to change the point position of this point which has been distributed using something like set positions. So let's do that. I'm going to use the set position node. Oops. Set position node for this point. And then now the position input becomes a field. So I can just use this value, a random vector value that I've created, connect it to this, and it will be applied to every distributed points available. And now the point has been replaced with this vector value, random vector values, and you can see that it's been distributed over a double size of this box. Let's group these with the frame. And next thing I would like to do is to define the animation, or run the animation so that the raining lines will go to this direction. Okay, so in order to do this, I'm going to use the frame-based value from Geometry Node or Blender 3.1. You can use a new node called Scene Time. So I'm going to use this Scene Time to actually create the animation. Now we already have a direction in which direction we want to move the rain lines to, which is this one right here. So I'm gonna just use this one to create the animation. Let's move this a little bit to the left. And first of all, the frame, I'm gonna use this frame value, which is counting up by 1 for each frame. And first thing I'm going to do is to multiply this by some value, which is going to be some speed related value. It could be any value. I'm going to try to start from 0.1 for now. And now this value will increase from 1 to the end of the frame and multiply by 0.0, so it will be 0.1, 0.2, 0.3, and so on. And this is, I'm going to use this value to be a moving distance for these lines. And the next thing I would like to do is to define the direction, which I already have here. So I'm going to multiply this vector rotate value here with a multiply, and multiply by this frame value. And now you have just created a vector value which increases by the frame to specific direction. Now what I'm going to do is to use this to move the point position, which is currently this random value here. And in order to change, you just need to add those two vectors together using a vector math. So let's create another vector math node and add this position by this moving distance or moving direction, multiply by scene time. And let's see how it goes. If I play it, you can see now that the line is moving toward the raining direction, and it just go down like that. Now you can see that the next problem is that it is running, it is animating, but doesn't go back to it's not respawning from when the rain goes below some threshold. It doesn't come back from somewhere around here. So next thing you want to do is to create some boundary informations, and if it goes outside a boundary, you want to respawn this line somewhere other side of the boundary, so that we can see the continuous raining. Okay, so let's also group these together using a frame. Select all these and Control P. Okay, let's move these a little bit to the right. Now, let's think about how we're going to respawn it. Well, in order to do that, we need to do some vector math. Think about how we can respawn from one place to another. So to do that, it's simple. It's more simple to think the vector values as separated x, y, and z coordinate. And let's think about this in numbers. Okay, so let's say the range for the x coordinate is in between -3 to 3 if the box size is equal to 6 and 6. Okay, and also the y is in between -3 to 3. Okay, so we're only going to think about x for now. And once the x goes over 3, meaning x goes something like 3.5 or something like that, you wanna respawn this or reset this x to a starting from 0.5 or something like that. Or if we have a -3 to 3, then it should be -2.5. So what it means is that moving this value, which is greater than 3, to be added to this minimum value. So if x is more than 3, then create a difference value, which is x minus maximum box value, which in this case 3, and then replace this x with a minimum plus d, and in this case a minimum is -3. So if the differences is 0.5, then you get -2.5 in this calculation. Now, in order to do these calculations in mathematical terms, you can just need to calculate the remains of the division. And in programming languages, you use this character to calculate the remains, which is called as modulus. And you do have the same things in Blender geometry nodes as well, so we're going to use this to calculate this conditions. In order to use this one, you do actually have to have the range in positive numbers. So instead of having -3 in this case, we need to remap the range from 0 to 6 or higher than 0 for the minimum value, also for the maximum value, to use this one. For example, if we have the range between 0 to 6, let's say if we have a 7 value and we want to remap this inside this range, what we can do is to divide with the 6, the maximum value 6. Then what we're going to have is a division value 1 and remain value 1. And this remain value is important. It tells you that the 7 is exceeding by 1 for this range, and can be remap in by adding this 1 to the minimum. So it becomes 0 plus 1 equal to 1. If it's 8, then the remains is 2, so this becomes 2, and so on. And by using this remain of the division of 6, the value is always in between 0 to 6. So that's the trick how you can make the value always inside the boundary. Okay, so let's try to use this one. Okay, so what we want to do is to remap this point position, which is right now outside the boundary. Okay, so in order to do this, we want to calculate the remains, and remains can also be calculated with vectors using vector math. So let's do this for every x, y, z coordinate at the same time. Okay, so first thing to do is to make the boundary positive, okay, by adding some vector value first to make the calculation positive first of all. Okay, so in order to do that, I am going to use the vector math with add expressions, and then add it with the size of the boundary, maybe multiplied by some really large numbers. So I'm going to create a group input, bring up this box size, and first thing to do, the box size itself is just a inside box, so and first thing I want to do is to double the size of the box, which is going to be used to respawn or change the point position based on the boundary. So I'm going to use the math node to multiply this box size by 2 first of all, and then I'm going to multiply this again by some big numbers, just to make sure that when I have added with the point position, it's going to be positive numbers. So I'm gonna let any number is fine, maybe 1000 is big enough, so I'm gonna make it 1000 and then add it with this point position. And just as I said, if you connect the float value to the vector input, all x, y, z will use the same value. Now let's assume that the point position has now become the positive number for both for all x, y, z coordinate. It's time to use the modulus to calculate the remains. So another vector math, set it to modulus, do we have it? I think we have it somewhere. Yep, this one, modulo. So connect the point position, the positive point position, and what we want to have for here is the divisional values, which in this case the double size of the box, so this one, the box size multiplied by 2. I'm gonna connect this to right here. As a result, you get a remains between 0 to box size multiplied by 2. Okay. Now the last thing you want to do is to make this in between the minus box size to positive box size again, but because I have made it positive. So in order to do that, you just need to subtract by a box size itself. So create another vector math node, make it subtract, and subtract with a box size. So previously, after modulus, the range was in between 0 to modulus multiplied by 2, but by subtracting by the box size, then the range becomes negative box size to a positive box size, which is the range we want to keep the point inside. Okay, now that we have this, let's reconnect the vector for the set position input to right here. You can see that the point position of the rain, the position of the rain has been set inside this boundary that I have set, which is 2 times box size. And if I play it, you can see that once the rain goes outside the range, or the box, it's been respawned from the other side. And if we change the direction, it should still work, even if it goes upward, like this. So, looking good. And let me also change the direction a little bit. Yeah, this looks like a good direction. Let's go to the next step. Now the next thing I would like to do is to set the size and the speed a bit randomish, because right now the speed and the size is constant. It's not that interesting to me, so let's change that. I'm first going to group these with the frame. So first of all, let's try to set the speed random so that some of the rain line goes faster, some of the rain line goes slower. Okay, to do this, we need to go back a little bit and come back to where we are setting the animation, which is somewhere around here. And this is the value which is defining the speed. If we increase this, it becomes really fast. If we make this smaller, it becomes slower. So I think it makes sense to change this value to random value so that we can have a various speed for the rain. So let's do this. I'm going to create a random value. And let's try to just connect this as it is from 0 to 1. And if I connect this, let's see what happens. So you can see it already creates some random speed. Some of the line goes slower, some of the line goes faster. So I would like to add a parameter in order to control the slowest speed and the fastest speed for this minimum and maximum. If I set the minimum to 0.1, you get the minimum speed to 0.1 per frame, and if it's 0.2, the maximum is 0.2 per frame, multiplied by the frame value. So, which is actually the moving distance per frame. So let's have both minimum and maximum as input. Let's go to the group input and add another parameter. Let's first set the first one to be speed minimum, starting from 0, and speed maximum, or let's say max speed, and this one to be minimum speed. Okay, and let's set the minimum speed 0.05 and maximum speed to 0.15 or something like that. Let's bring up the group input and connect the minimum speed to random minimum, max speed to maximum random. Okay, it looks good. So that's it for the speed. Let's try to change the size now. Now, in order to change the size or length of this lines, the raining lines, since these are instances, what we can use is, for example, change the scale here, or use a node like instance scale instances. So I'm going to use this scale instances to change the size of these lines randomly. And it's pretty easy to do. You just need to connect the instance to this scale instances, and what you just need to do is to set this scale with a random value again. So create another random value. I'm gonna make it as a float value because I want to set every x, y, and z value to be the same value. So connect it right here. And for a minimum, maximum, again, we could set any kind of numbers, and you can see that the length, the size of the line is changing based on this minimum maximum randomly. Okay, which makes it more organic. Okay, so looks good. I am going to create another input to define the minimum size and the maximum size, or minimum scale or maximum scale. So let's name the first one to min scale and max scale for the second one. Now for the minimum scale, let's say 1 is the minimum and 1.5 is maximum. Okay, let's bring up the group input again and connect the min scale to min, max scale to max. Maybe I can differentiate this a little bit. 0.5 to 2. Alright, looks good. So that's it for changing the scale of the size random. I'm gonna connect all these with a frame now. Create a frame like that. Now everything is pretty much done here. The last thing I need to do is to create the shadings, and right now you can see that at the end it's just the line is just disappearing and respawn at the very end. So I want to make it a bit more smoother in terms of the appearance and the disappearance. So I'm going to create a small bounding box, which is the original size of the box was defined right here. So which is half size of this bounding box, and use that to trim out these lines using a shader. And also, since this is a rain, it might be a good idea to create the floor. So first let's create the floor, which is just a simple cube, the sized cube. So let's do that. I'm going to create a cube, and let's set the size of the x and y the same as the box size, and for the z value, let's make it like the thickness of the floor. So maybe thinner than the box size. Okay, so let's do this by first of all bringing up the group input, which has this input box size. Let's create a vector value using combine x, y, z, and for the x and y I'm going to set x and y. Okay, and for the z value, it could be any kind of value, maybe a multiplication of this box size. So create a math node, multiply, set the multiply, and multiply it by, I don't know, 0.2 or something like that. Connect this to z, and then connect this combined xyz to the size of the cube. Now let's check this out, how it looks like by connecting to a group output. Looks like these. Maybe it's a bit too thick for me. Let's make it 0.1. Okay, looks a little bit better, so let's go with this. Okay, now let's connect this back, and let's create a join geometry so that we can show two geometry at once, both rain and the floor. Okay, now since a box is placed on the center, we need to move this floor a little bit to the negative z direction, the half size of the box. So let's do that by using a transform node, using translations to move to a z direction. So let's create another combine xyz to create a vector value. We need to move it to the negative z direction by the half size of the box size. So calculate the box size multiplied by negative 0.5, and then connect this to z and connect the vector value to a translation. Now the floor comes to somewhere around here. Okay, so it looks good. Now it's time to set the shader or a material to both of the geometry for the rain and the floor, and we're going to create the shaders. Let's create the frame to group these first of all. Okay, now in order to create the shaders, first of all, I am going to create the set material for both rain and the floor. Oops. Let's make this outside the frame. Connect it to a floor. Okay, so we haven't created the material yet, so let's do this both for the rain and the floor. So going to the material tab, we do have a single material being created as a default, so let's change this name to floor first. Let's start by creating the floor material, which is going to be easier because it's just a single color. Let's set this to floor. Now let's duplicate this material and then change the name to rain and set the raining material to rain. Okay, now we are ready to change the material settings for both floor and material, for floor and rain. So I'm gonna use the EV to create the shader. I'm gonna change first of all the viewport shading. Okay, looks like this. And let's start by setting the floor material or shading. Let's change the spreadsheet view to a shader editor and change this to floor. Okay, so for the floor, I'm going to just set the single color, and probably I'm gonna use the subsurface to make it a bit translucent material. So let's create a color, or I'm just gonna change this surface color to kind of yellowish color, like that. Increase the surface. It already looks nice. And let's see if I change the light to 1000, becomes brighter. Maybe 2000. Looks nice. A little bit more for 1000. Okay, so I think it's probably good enough. Let's move this a little bit to the side. Alright. Well, anyway, it looks okay to me. Somewhere around here. Maybe increase the brightness a little bit more. So in terms of the floor, I think it's fine. So let's try to change the shading for the rain. Now, for the raining, what we need to do is to trim these rain based on the size of the box. So what we need to do is to bring up this parameter box size to the shader as an attribute. So to do that, we need to give this group output an output parameter or output input defined right here. So let's click a plus button and then name this as box or just size. And if we look at the geometry node modifier out in to a output attributes, you see this size here. Let's name this the same name as this output name size, which is going to be used inside a shader to refer to. Okay, and we might also want to change the color of the rain randomly. So let's also create another output named as random value, which which is also bringed as an attribute. Okay. So we have two output we want to bring to the shader. One is the size and one is the random value. The size itself can be retrieved from the group input, which is this box size. So let's just connect it like this. For the random value, it could be a value in between 0 to 1. Any value in between 0 to 1 is fine. So let's just create another random value and just connect it right here. And that's pretty much it. Now, one thing you need to remember that in order to bring the attributes from the geometry nodes to a shader, if you check the spreadsheet, you see that the attribute is only being created to the vertices, and you see that the vertices is only 8, which is for this floor geometry. And you can see that those raining geometry is not shown inside this vertex, but instead it is shown inside this instances. And you see that there are no attributes named size or random in instances. So if you want to use these size attributes or a random attributes for these instances, what you need to do is to, you cannot actually use it for instance. Instead, you need to make these instances back to a original mesh or the mesh geometry by using a realize node. So we're going to use the realize instances, make this back to a geometry, which makes the calculation a bit slower, but the setup is pretty simple. I think we could still see it as real time as an animation, so I think it's not a big problem to actually realize instances. So look fine, and if we go back to the vertices, now we have a bunch of random values as well as the size attributes being placed on each points. Okay, let's go back to the shader editor. Okay, for the rain, let's bring up those attributes that I have just sent using a attribute node. Now there are two attributes that I brought. One is the size. So let's write size, and that is a fractional value, so coming from this FAC here. And what I'm going to use this for is to change the or the clip this raining geometry inside this box. So to do that, we are going to use the same similar things that I did in order to respawn the rain that goes outside a boundary, which is to use the modulus. Okay, and use that information for the alpha information for this material. And in order to use the material with the alpha node, I think we need to set some settings for this material itself. So let's go to the material tab and go underneath, and right now the blend mode is set to opaque. So instead of opaque, I'm gonna change this to alpha clip, using alpha value to clip the geometry based on this alpha channel right here. So if it goes to 0, it just disappears. If it's more than 0, it appears. So what I want to do is to set those geometries outside the boundary to be 0 in terms of the alpha, and if it's inside the box, then set the alpha to 1 or more than 0. So in order to define that, we need to check the position for each of the position of this geometry by using a geometry node and use this position value. we want to check if this position is inside the boundary box or outside the boundary box. And if it's outside, set the alpha to 0. If it's inside, set the alpha to 1. Okay, so let's do this. And since we are dealing with the point position, which could go negative value, but we only want to, as I said, the modulus can only use for a positive value. First thing I would like to do is to set this positions for the all x, y, z coordinate to be positive by using, in this case, an absolute function. So making absolute, you can multiply the negative value by -1 so that every value will be positive. Okay, now now that I have an absolute value, it's time to check whether the size is over box size or not. Okay, now I have this box size right here, so let's first of all multiply this by 0.5 because the box size is this size, but if we look at the axis, what we need to check is the half size of the box for the x, y, and z. So multiply this by 0.5. Okay, and then what we want to do is to calculate or the divisions in this case. Maybe not the modulus, because yeah, we want to check if it's outside or inside, so I think it's the division itself just makes sense in this case. Meaning if the division between, let's say, vector math division, so if the division between the absolute value of the point position and the box size, half of the box size, and if it's more than 1, then that means it's outside. If it's less than 1, if it's within 0 to 1, then that means that the point positions is inside the box. So that's how we can assume whether the point is inside or outside the box. Now what we need to check is whether x, y, or z is outside or not. And if just one of the coordinate is outside the box, then you just want to make it transparent. So the best way to check is to first of all get the minimum value between x, y, and z, get the least values out of those 3 coordinates, and check if this minimum value is either in between 0 to 1 or more than 1. Okay, so let's do that. And in order to do that, first of all, I'm going to separate this xyz value and check the least value out of these xyz by using math node minimum, which we have it right here. So minimum, first of all, we calculate the minimum between x and y, then use the same minimum to compare between the result and z. As a result, you get the least number out of these x, y, and z, and what we need to do next is to check whether this is larger than 1 or less than 1. We can do that by using another math node with the floor. So if it's in between 0 to 1, then the floor value will give you a value 0. If it's more than 1, then you get the value more than 1. And you just need the value for this alpha, whether it's 0 or more than 1, more than 0. So this should just do the job. And if you connect this one, now it looks like it was other way around. If if it's 0, it looks like it's just disappear. So we need to make this flipped. Okay, so in order to flip this, let's go back a little bit and let's first of all clamp this divisional value in between 0 to 1. Okay, in order to do that, this has to be 0.5, and in order to do that, first of all, I am going to let's say get the minimum between the box size and the positional size using the vector math node. Get the minimum so that the value is going to be clumped with a absolute value of the box size multiplied by 0.5, and then use this value with the division. Okay, and so this value goes to right here, and it will give you a value in between 0 to 1 in this case. Okay, now so what I want to do next is to subtract this value with 1. Vector math node, do the subtraction. 1 subtract by this value. Okay, and then connect it right here. Now this will give you a value in between 0 to 1 flipped, and we are now getting the minimum value between x, y, and z. And now I don't think we need to do the floor, and as a result you get a clamped or trimmed lines inside the box boundary. Okay, looks good. Let's increase an amount of reins which were under the geometry nodes. Right now the point number is 135. Let's increase this to 200 to see more dense. Maybe a little bit more, 400. Yeah, starting to get more dense infos. Let's also rotate this a little bit like that. Alright, it's working great. So now the line has been trimmed. You no longer see a jumping lines anymore. Okay, I might want to deal with this blurry shadow or blocky shadows a little bit. So going into the scene, checking the shadows, maybe increase the resolutions a little bit. If you have enough CPU or a GPU, check the high bit depths. Makes it a little bit better in real time. Okay, now looks good in terms of the clipping. Now the next thing I would like to do is to set the shading of the rain, and that's pretty much it. Okay, so in order to do that, I'm going to use the other attributes that I have exported, which is the random value. Let's create the attributes and let's import the random value. Okay, so I'm also would like to set the color based on the height of the rain. So if it's close to the floor, maybe we can use some yellowish color. If it's above the floor, maybe we can use somewhere close to blue. And combining with some randomness, let's create some color gradients. So let's also get a geometry node and get the point position. And what we want to refer to is the z-axis or z-coordinate of this point to get the height. So separate xyz get the z value, and let's try to use this. Okay. Now, it also makes sense to remap this z value together with the box size so that we can normalize this in between 0 to 1. So get the attribute again with the size, which is the box size, and let's remap this z with the box size so that we can normalize this. Let's map range, the z value, which should be in between negative box size, half of the box size, and positive half of the box size. So let's multiply this box size by 0.5 as well as negative 0.5. Okay, set this to from max and set this to from min, and remap the target to 0 to 1, which is similar to normalizing the value. Okay, now that I have this value, I'm going to then create some relation with this random value. I'm not sure what's the best way to compare it or have the relation, but I could use something like a minimize. So get the smaller value from the map range, the normalized map range, and this random value, and use either of the value for the color range. So now that I have this value, I could now use this to create a gradient using color ramp. Connect this to a fractional value, and then connect the output color to some place. Since I would like to make the rain shiny, maybe it might be interesting to set it into an emission so that it could also emit the light. And the strength of the emission, maybe 10 is fine. And let's also check the bloom option so that it looks like it's it's shining. Or you can also increase this value if you want. Okay, so it looks good. And although the colors right now seems just a whitish, so let's see if we could change the color based on those values. Right now it's black to white, doesn't really make any changes, but let's see if I change this color to something else. Like for example, if I set this to yellow, I do see some changes. Some of the color became yellow, like that. Not really sure yet in which place the color became yellow. So let's add another colors in between. For example, this color, make it bluish. Make another color, maybe this one, to be a bit more darker blue. And add another color, make it a darker color like black. Let's see. And now we can see a little bit of gradients. You can see that some of the some part of the lines at the bottom, you see this orangish color, and at the top you do sometimes you do see some orangish, but most of the time you see bluish color. That is because we are having this random values right here. If we don't have this random color, then it's more of a gradient color from orange to blue. But by having this randomish color, you could somehow spread this color overall, but keeping the ratio of the height. Okay, that looks good, and that's pretty much it in terms of this settings, procedural raining settings. So let's group these out. Okay, like that. So this is the final setup for the shading, the rainy shadings. Let's also frame these together. Frame. Okay, now let's organize these a little bit. And in terms of the view, I like orthogonal view a lot, so I'm gonna make it like that. Alright, hide out all those grids and stuff, and let's try to change those parameters that I have set. Like number of rains, make it 1000, set the speed faster at some point. And for the scaling, let's set the minimum to be really small and the maximum to be a bit smaller as well. Yep, it's nice. Maybe the shadow is a bit too strong. Maybe I don't really need the shadow itself after all. So uncheck shadows. Still looks good. Okay, and I could also increase the amount of frame by increasing this one, maybe like 5000. And there you go. Maybe you could also change the rotation of this to see in which direction it runs best for this setup. Yeah, like it this. Looks nice. So this is it. And what's interesting about this setup is that you could also change the direction. Oops, not this one. Change the direction to rain upward, which is surreal, but still possible. Like that. Like a shooting star. Alright, so that's it. That's pretty much it for this tutorial. I hope you like it and find something new within this process. I'm also doing a Patreon myself, so if you would like to support creating these kind of tutorial, I'll be appreciated. Okay, so thank you very much and see you next time.